Hello students, welcome to Vincent Maths. This is Shumit Mujumdar, and today, as you can see in the thumbnail, our topic of discussion is to derive the equation, the polar equation of straight line. And this is the third lecture of this series. If you haven't still watched my previous videos on polar coordinate system, here I share the link of the playlist in the I button, so you can check it out. And students, this session is going to be very interesting. In this session, we'll first derive the equation of straight line in polar form. Then we shall observe some specific cases also, and then we shall derive the equation of parallel straight lines and perpendicular straight lines. And not only the derivations, students, I'll explain you the concept with proper neat and clean diagram. So and finally we shall solve a problem also, and through that problem we'll learn a concept actually. So all you have to do is to take your pen and notebook and continue with the video with a positive mindset. So let's start. So first we draw our polar coordinate system. This is O, our pole, and OX is the initial line. Now there is a straight line AB given in this polar system, and we have to find the equation of this straight line AB, okay, using polar coordinates. Now one more thing is given in here, that is the distance of this straight line from the pole. Distance means obviously the perpendicular distance. So if we draw a perpendicular from O to this straight line and denote the foot by N, then this distance is given as P units, and this angle means the angle made by ON with the initial line is given as alpha. So we can say that the coordinate of point N is P comma alpha. Now we have to find the equation of this straight line A. So let us first consider an arbitrary point on this straight line, say M r comma theta. Okay, you can take this anywhere on this straight line. This is a variable point. Variable point means this point moves along this straight line AB. So if we can find the locus of this point A, then we shall derive the equation of this straight line AB. So we'll first connect this point A to the pole. Then we can say that this MON is a right angle triangle, obviously, because this angle is 90 degree. So now by the coordinate of N, this length ON is R units. This length ON is R units, and this entire angle is theta. Now obviously if this greater angle is theta and this smaller angle is alpha, then we can say this little angle, that is the angle MON, is equal to theta minus alpha, isn't it? Okay. Now in this triangle MON, in triangle MON, cos of angle MON is equal to base upon hypotenuse. So the base is ON divided by the hypotenuse, that is ON. Okay. So now angle MON is nothing but theta minus alpha. So we can write cos of theta minus alpha is equal to ON by ON. Now ON is this length, which is given as P units, and OM is this length, which is, we know by the coordinate of N, is R unit. So from here we can write P is equal to R into cos of theta minus alpha. So this is the required equation of straight line in polar form. Okay, now we shall expand this equation to find its general form. We'll just use the trigonometric formula. We know cos A minus B is equal to cos A cos B plus sin A sin B. So we'll expand this cos theta minus alpha. Then we get P is equal to R cos theta cos alpha plus R into sin theta sin alpha. Okay. So this is, from here we can write, if we divide both sides by PR, we will get P by PR is equal to R cos alpha by PR into cos theta plus R sin alpha by PR into sin theta. Okay. So from here we can write R cancel, then we get 1 by R is equal to, now see, cos alpha by P is a constant and sin alpha by P is also a constant. So we can write this like this: A cos theta plus B sin theta, where we must mention where A is equal to cos alpha by P and B is equal to sin alpha by P. Okay. Now students, this is the general form of the equation of straight line. Okay. So this is the polar form and this is the general form. This is polar form and this is the general form. Both are important and useful also. Okay. Now one more thing you must remember here, that I have written this like 1 by R is equal to A cos theta plus B sin theta, but we can write this also as K by R. K by R is equal to A cos theta plus B sin theta. It means here we can write any constant. Okay, just what we have to do is to multiply this constant here also. Okay, so A becomes K cos alpha by P and B becomes K sin alpha by P. This is very useful because later when we shall derive the equation of chord passing through 2 points to the conic L by R is equal to 1 minus E cos theta, we shall use this particular formula to derive the equation of that chord. Okay, where this constant is actually L and L is nothing but the length of semilateral rectum of that conic. So we just have to remember that this is the general form of the equation of straight line and this is the polar form of the equation of straight line. Okay, now we shall move forward to some special cases. First we should note it down. I am leaving the screen here. Okay students, now we shall observe some special cases. Okay, special cases. Case 1. If alpha is equal to 0, okay, if alpha is equal to 0, then the straight line AB will be perpendicular to the initial line OX. Okay, if alpha is equal to 0, then the straight line AB will be perpendicular to the initial line OX. How? You have to understand the geometrical interpretation also. You should understand because it will help you to remember the concept clearly. So, if we draw our coordinate axis, this is O, pole and OX is the initial line. Then AB is a straight line. AB is a given straight line. Okay. Now, a perpendicular is dropped from O to AB. This is ON. Okay. So, we know that the coordinate of point N is given as P comma alpha. So this angle is alpha. Now alpha becomes 0. Here I have 2 sticks of channel files to elaborate this. So say this is our straight line AB and this is the perpendicular OL. Okay. Now I am decreasing this angle alpha. and this angle alpha becomes 0. When this angle alpha becomes 0, then the straight line AB is perpendicular to the initial line OX. So thus, if alpha becomes 0, then the straight line AB is perpendicular to the initial line OX. Then the equation will be P is equal to R cos theta. Theta minus alpha, and alpha is equal to 0. So the equation is P is equal to R cos theta. The second case is if alpha is equal to pi by 2. If alpha is equal to pi by 2, it implies that AD is parallel to OX, means the straight line AD is parallel to the initial line OX. You can see this is our AD and this is ON. So I am increasing this angle alpha, increasing, and this becomes 90 degree. So if alpha becomes 90 degree, then this straight line AB is parallel to the initial line OX. So thus if alpha becomes pi by 2, then the straight line is parallel to the initial line. Thus the equation will be P is equal to R cos theta minus alpha is pi by 2. From here we can write P is equal to R sin theta. Okay, so these are two special cases you have to remember. One more special case is there, that is case 3. If P is equal to 0, then the straight line, the line passes through pole. Okay, it's very easy. Just see this distance P. This is the distance P, and if this becomes 0, then the straight line will come here. It means the straight line it passes through the origin or pole. Okay, so thus the equation becomes R cos theta minus alpha is equal to T, and T is equal to 0. So this is equal to 0. That is equal to cos pi by 2. Okay, from here we can write theta minus alpha is equal to pi by 2. So theta is equal to pi by 2 plus alpha. Okay, so this is a constant. This is a constant. Okay, so if P is equal to 0, then the straight line passes through the origin and theta becomes a constant. These are three special cases. You must know these special cases. Now we shall derive the equation of parallel straight lines and perpendicular straight lines. First, you should note it down. I am leaving the screen. Okay, students. Now we shall derive the equation of parallel straight lines and perpendicular straight lines. And this is very interesting topic, students. I'll urge you, here I am drawing two diagrams, so I'll urge you to draw it on your own. But first, you listen carefully and understand the topic, understand the concept. Okay, so first parallel straight line. Parallel lines. Perpendicular lines. Okay, so I'm drawing here two diagrams. OX is the initial line. Now AB is the given straight line. and we know its equation in polar form. AB is L by R. In polar form, the equation of AB is given as P is equal to R cos theta minus alpha. Okay, and we draw a straight line which is parallel to AB, and denote this straight line. We write this is the straight line CD. Okay, so this straight line is parallel to AB, and we have to find its equation in polar form. Okay, now we know that this distance is P units, and say this is the distance of CD from say this is point M and this is point N. Okay, now we know ON is the distance of line AB from origin, so we know this is P units, and this distance ON is the distance of line CD from the pole. Okay, so let this distance be P dash. So ON is equal to P and ON is equal to P dash. Okay, now students, this angle is alpha. So the equation of this straight line CD in polar form will be P dash is equal to R cos theta minus alpha. Okay, means we just have to change this distance P dash, because this is the distance of the straight line from pole. This is the concept for the parallel straight lines. In case of parallel straight lines, we just have to change this distance. This distance means the radius vector of this point A and point A are different, but the vectorial angles are same. Both are alpha for parallel straight lines. This vectorial angle is same. Okay, so if we want to write its general form, if the general form of AB is L by R, K by R is equal to A cos theta plus B sin theta, then the general form of CD will be K dash by R is equal to A cos theta plus B sin theta. Okay, so this is the concept for parallel straight lines. For parallel straight lines, we just have to change this distance P. Here it is P dash. Okay, but the remaining terms are same for both the straight lines. Okay, in case of general form, you can see here we have written K and here we have written K dash. Okay, this is the concept for parallel straight lines. But in case of perpendicular straight lines, we need to change both the distance and also the angle, and we change the angle by a difference of pi by 2. Okay, so I am drawing the diagram here. Okay, so OX is the initial line, and the straight line AB is given, whose equation we know its equation is P is equal to R cos theta minus alpha. Okay, we have to find the equation of a straight line which is perpendicular to this straight line. So if that straight line is like this is perpendicular to AB, and this is the equation, this is the straight line CD. So we have to find the equation of CD. Now we know that if we draw a perpendicular from O to the straight line AB, this is ON. Okay, and this is a perpendicular to the straight line. Then we know this length is P units. Say this is P units, and this angle is alpha. Okay. Now observe carefully, students. This straight line CD is parallel to the straight line ON, because this is also perpendicular to AB and this is also perpendicular to AB. So these two straight lines CD and OM are parallel, we can say that OMCD is parallel to OM, isn't it? Okay. So we just have to find the equation of CD. Now we shall draw one more perpendicular from origin to CD. Then we know, okay. So 1 minute, I'll extend this here. This is C, and let the foot of the perpendicular be denoted by point M. Okay, so the coordinate of M we can write, if this distance is P dashed, then we can write the coordinate of M is P dash comma. This angle is 90 degree and this angle is alpha. So its vectorial angle will be equal to this entire angle, that is alpha plus pi by 2. So alpha plus pi by 2. This is the coordinate of point M. It means in case of parallel straight lines, we just have to change this distance P and we get the required equation. But in case of perpendicular straight lines, we need to change the radius vector as well as the vectorial angle also. And the vectorial angle is defined by a difference of pi by 2. Okay, because these are perpendicular straight lines. Now we should put these values in the equation and we will get the equation of CD is in polar form. P, in place of P we will write P dash is equal to R cos of theta minus alpha. In place of alpha we will write alpha plus pi by 2. So R cos theta minus pi by 2 minus alpha. Okay, and this becomes P dash is equal to R sin theta minus alpha. This is the polar form, and in general form we will write K dash by R. K dash by R is equal to, in place of theta we will just write theta plus pi by 2. So we will get D cos theta minus A sin theta. Okay, this is the required equation. Okay, so this is the required equation of straight line in polar form and general form. So you just have to remember these diagrams, that in case of parallel lines we just have to change the radius vector, but the vectorial angle remains same since these are parallel lines. But in case of perpendicular lines, the radius vector, not only the radius vector, we have to change the angle also, and the angle is changed by pi by 2 since these are perpendicular straight lines. Okay, thus this is the polar form of the equation parallel lines, and this is the general form of the equations of parallel lines. Similarly, this is the polar form of the equation of perpendicular line, and this is the general form of equation of perpendicular lines. Okay, now we shall study one more concept. Actually, we will solve a problem, and through that problem we shall learn a concept. So first you should note it down. Okay students, now we should solve a problem. See, find the condition of line, find the equation of line passing through points r1 theta 1 and r2 theta 2. Hence obtain the condition of collinearity of r1 theta 1, r2 theta 2 and r3 theta 3. Okay, so basically we have to find a line which passes through two given points, r1 theta 1 and r2 theta 2. Okay, so let the equation of the line be denoted by, we will write the general equation. So let the equation of the line be k by r, or say 1 by r. 1 by r is equal to a cos theta plus b sin theta. Okay, this is the equation of the line, we suppose. Okay, now since the line passes through these 2 points, the points r1 theta 1 and r2 theta 2 must satisfy this equation. So this is our equation 1. Okay, So r1 theta 1 and r2 theta 2 must satisfy this equation. Hence we obtain, putting those points here in the equation, we obtain 1 by r1 is equal to a cos theta 1 plus b sin theta 1. This is our equation number 2, and 1 by r2 is equal to a cos theta 2 plus b sin theta 2. This is our equation number 3. Okay, so now if we solve these three equations, we will get the required equation of the line. So you can use the cross multiplication method, but I will use here the determinant method. It's easier. Okay, so we will write the determinant. One by r, 1 by r1, 1 by r2, sin theta 1, sin theta 2, and cos theta 1, cos theta 2. This determinant equals to 0. This is the required equation of the straight line. Okay, now if we expand this determinant, you will find the equation, and that is, I am not expanding the determinant here, you can do it yourself. So the equation of the straight line will be like this: 1 by r into sin theta 1 minus theta 2 plus 1 by r1 into sin theta 2 minus theta plus 1 by r2 into sin theta minus theta 1 is equal to 0. This is the required equation of straight line passing through two given points r1 theta 1 and r2 theta 2. Okay, now the second part says to obtain the condition of collinearity of these 3 points. Now listen carefully. If these 3 points are collinear, I have explained this concept in my previous video in finding the area of triangle. So if these 3 points are collinear, it means these points lie in the same line. Okay, so these 3 points in this equation, we have taken 2 points r1 theta 1 and r2 theta 2, and one more point was there, that is the arbitrary point r1 theta. Okay, but in case of 3 points, you can take this arbitrary point in place. We can replace this by r3 comma theta 3, and then if we can satisfy these 3 points here, we will get the condition of collinearity of these 3 points. So that is nothing. We just have to write it here. In place of r, we will write r3, and in place of theta, we will write theta 3. This is the condition of collinearity. So this becomes r3 and this becomes theta 3. This is also theta 3. Okay, so 1 by r3 into sin theta 1 minus theta plus 1 by r1 sin theta 2 minus theta 3 plus 1 by r2 sin theta 3 minus theta 1 is equal to 0. This is the condition of collinearity. Okay, so this is the condition of collinearity. So this is all for today's session. and I hope you have understood the concept clearly. If you have any doubts regarding the discussion, you can let me know in the comment section. Also, for the PDF notes of this session, you can check out the description box. And thank you for watching my video.